Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a problem on pure bending. So this is the problem over here. A wooden beam with a loading and cross section is given. Find maximum tensile and compressive stress due to bending. So this is the beam and the loading. So if you see the loading, the bending moment diagram will be non-uniform because the bending moment will not be constant over here. So it is not the case of pure bending, it is non-uniform bending. But already we said that we can use the formula of pure bending for small element of this non-uniform bending. Okay. So sigma max will be is equals to m max into y divided by I, right? So first we need to find out m max. So for m max, this is P1 and this is P2. Then this will be 50 kilonewtons and this will be acting at 22 into 6.7. Okay, and this will be 6.7 divided by 2. So we can calculate P1 by applying moment equilibrium at P. So we get 22 into 6.7 into 6.7 divided by 2 plus 50 into 6.7 minus 2.5. That will be is equals to P1 into 6.7, right? So let us calculate the value. 22 into 6.7 into 6.7 divided by 2 plus 50 into 4.2, I think, yes, divided by 6.7. So we are getting P1 as 105.04 kilonewtons. So we need to find out m max. So for m max, dm by dx should be 0. That means v is equals to 0. Okay. Let us take a cross section. Then we get P1 105.04 minus, this is at distance x, then that will be 22x minus 50 will be is equals to 0. Okay. So from this we get minus 50 divided by 22. X is equals to 2.501967. Means it is just right to the P is equals to 50 kilonewton because that is at distance 2.5, just right to the P. Okay. So at this position, the bending moment will be maximum. So we can directly calculate the bending moment at that position. So we can write this is P and this X is 2.5 nearly. So the Q will act at 2.22 into 2.5. This distance will be 2.5 by 2. Okay. And the P is acting over here. The P is 50 kilonewtons. We need to find out M over here. Okay. So M will be is equals to, let us take moment equilibrium about this point, and that will be is equals to P 105.04 into 2.5 minus 22 into 2.5 to 2.5 divided by 2. Okay. So that will be 105.04 into 2.5 minus 22 11 into 2.5 into 2.5. So this is, we are getting the value of M max as 193.85 kilonewtons, right? So what we need to find out? We need to find maximum tensile and compressive stress due to bending. So if you see the cross sectional area, that is a rectangular cross sectional area, and see the loading on the beam. Suppose this is the beam, the loading on the beam is like this, right? So it will bend like this. So if it is bending like this, so the bending moment is something like this. So the axis which we need to take for calculation of I will be this one, because the bending moment is this. The vector representation will be like this, right? So the axis should be this one. So if we draw the axis over here, that should be this one, right? And the neutral axis will present at the centroid. So this distance will be h by 2 and this distance will be h by 2. So the magnitude of tensile stress and compressive stress will be same. So magnitude of tensile stress, maximum tensile stress, and magnitude of maximum compressive stress will be same, because it is doubly symmetric. So now we need to find out I. So I is BH cube by 12. So B is 220 into H cube, 700 whole cube divided by 12 mm power 4. Okay, this is I, and we know the Y value, that is H by 2, that is 350 mm. So sigma max will be is equals to M max 193.85 into 10 cube into Y, that is 350 into 10 power minus 3, divided by 1 by 12 to 220 to 700 whole cube into mm power 4. Mm power 4 is 10 power minus 12, so 10 power 12. Okay, so this gets cancelled. So we can write sigma max is equals to 193.85 into 350 into 10 power 6 divided by 1 by 12 into 220 into 700 power cube megapascals, because here it will be pascals. So if we take 10 power 6 pascals, we can write it as megapascals. So if we calculate this value, we are getting the value as 10.8 megapascals. So sigma max tensile will be is equals to 10.8 megapascals, and sigma max compressive will be is equals to minus 10.8 megapascals. So this is first part of the question. If you see the second part, if Q is unchanged, maximum permissible load P, if sigma allowable is equals to 13 megapascals in compression and tension. So now we need to find out maximum load P we can apply such that the maximum stress in the beam, bending stress in the beam is 13 megapascals. So now just replace 50 kilonewtons by P and calculate M max. So if you calculate M max by replacing P, we will get, I am not calculating that, M max will be, for part B, will be 1.57 P plus 0.56, okay, kilonewtons. This is M max. So we already know the Y, that is H by 2, 350 mm, and we already know the I, that is 1 by 12 into 220 into 700 whole cube mm power 4. So just substitute these values in sigma allowable is equals to M max H by 2 divided by I. So sigma allowable is 13 megapascals. So 13, 1.57 P into 115.56 into 10 power 6 into H by 2 is 350 divided by 1 by 2, 12, this is 12, into 220 into 700 whole cube. So if we calculate this, we get value of P as 75.4 kilonewtons. Okay, this is the P permissible value. Understood? So before ending today's lectures, let us discuss one concept. See, for a in a given cross section, in case of bending, some portion will undergo tensile stress and some portion will undergo compressive stress. So suppose this is undergoing tensile stress and a straight line if we draw, this will undergo compressive stress, right? So this is compressive stress and this is tensile stress. But in this cross section, the net normal force in this cross section, the net internal normal force should be zero because we are only applying we are not applying any axial forces. So the net force applied by tension plus the net force applied by compressive stress should be is equals to zero. So in magnitude, the net force applied by tensile stress should be is equal to the net force applied by compressive stress. This is an important point because in some questions they can ask what is the net force, what is the force applied by the tensile stress, net force due to the tensile stress. See, in that case, suppose if you take a I beam section, so then this neutral axis will be somewhere here. Suppose this portion is in tension and this portion is in compression, and they asked for find ft, magnitude of ft. Then what will you do? See, if you go and solve this one, it will take somewhat more time. So you can calculate the fc over here, which is easy. So calculate fc as mod ft is equals to mod fc. So we need to calculate the easier one. Okay. So this is one more concept. I hope you understood this concept. So with this, we end today's lecture. In next lecture, we are going to solve one more problem on pure bending. If you like this lecture, do subscribe to our channel, Ninepointer. Thank you.